Okay, today we got a problem which I was looking at for a long time in the list, which is 994 rotting oranges medium. So we have some grid with empty cells, fresh oranges, rotten oranges, and every minute any fresh orange that is 4-directionally adjacent to a rotten orange becomes rotten. Return minimum number of images that must elapse until no cell has a fresh orange. Return if this is impossible. Okay. I mean, I don't understand why the coordinates immediately what I see are so low, but it is what it is. And let's see, make this smaller. So okay, well, this is rotten. They could at least change the color, but basically what we want to do is run a BFS, but a little modified BFS such that we don't process one node at a time but entire levels at the time, and that's it. Okay, and then we do this. So Q, DQ, Q append, if grid ij is 2, so we have a rotten orange, we add it to the queue. Not sure why it's okay. Now while queue is this, then we keep a new queue. Let's call it like visit it. Question is, can we do it in place? Good question. So we make visit it, right? And now for, so this is the trick, iteration is this, and then for vertex in queue, not sure if we can do this, but whatever, or ij or CICJ, and then for DIDJ in and if we are inside and not visit it, and then we do so I guess I should put visited here. And then this ij is 1 and this is 1 and nq append ni and j, and finally q is new q, and then we do like iteration plus equals 1, and then we go through the grid. If there is a rotten orange and it's not visited, we return -1, otherwise we return iteration, right? 1, 2, 3, 4. we don't have to do this. If len mq like that. What the hell? Oh, and Greek ij. Okay. So this should pass. So let's write an editorial real quick. So label BFS O NM or NM like this. So need to do a BFS processing entire levels by distance from the rotten oranges and count iterations levels processed. First we put all rotten oranges in a queue, and then in iterations we what? And then in iterations we create an empty queue, and for each node in the current queue we process it and insert any new nodes any neighboring unvisited oranges into the new queue. Finally, when we process all oranges of the old queue, we change the new update the old queue to ONM, where n is the number of the rows and m is the number of the columns. Since we just do a grid on the we just do a BFS on the grid, n plus m, where n is the number of the nodes and m is the number the edges, which is O and m plus nm O and m in a graph created from a grid. O and m, since we store revisited matrix, and in worst case all cells are in the queue at a single time. That's it, post. Okay, goodbye.